The Chevrolet Camaro was pulled off the market in 2002 when sales slumped. But this loud classic is back with a vengeance.
I can tell you that I've driven a Camaro through my neighborhood and people hear me coming and they come and want to see the car.
Here, at one of the largest car factories in the world, these new models are stamped from cold, raw steel.
We are capable of producing upwards of 25,000 pieces per shift.
Honed using high technology.
18 hours later, we're getting set to drive a Camaro off the end of the line.
And assembled by cutting-edge robots.
Robots are strong, they're dependable.
To build the ultimate muscle car, you need a mega factory. It's a symbol of power, as American as apple pie, and the dream of hot rodding teams, the Chevy Camaro. From its cowl induction-style bonnet to its crosshatch grille and rear quarter gills, this hard-charging, snarling icon of raw performance is a legend. For 35 years, the Camaro defined an American class of road warriors, the muscle car, burly, souped-up, high-speed roadsters. When sales slumped, production stopped with the 2002 model, but its cutting-edge styling, nostalgic appeal, and a starring role in the Hollywood blockbuster Transformers have made the Chevrolet Camaro one of the most anticipated comeback cars. The challenge of building this American icon ironically fell to two GM factories in Canada. The St. Catharines factory is where the powerhouse engine is built, and the Oshawa factory is where the Camaro is assembled. The assembly plant covers a whopping 790,000 square meters. And it has a unique workforce. Robots, nearly 1,000 of them. The Camaro comes together in the body shop. Paint, trim, chassis, and testing areas. But the process begins in stamping. Here, massive stamping dies will stamp the body panels from steel and the bonnet from aluminium.
This is right where it all begins. You start at the front of the car, which is the hood. You move to the fenders, we stamp those. Then we stamp the roofs, and then we stamp the doors.
All of these pieces will begin as a flat sheet of metal.
The metal on the pallet that you're seeing behind me is 0.8 millimeters cold roll steel. The 0.8 millimeters is basically equivalent to 10 human hairs stacked together.
This press is stamping the roof from a 4.6 meter square sheet of steel weighing approximately 9 kilograms. The lifting arm effortlessly picks up the steel like a piece of paper, feeds it down a conveyor belt and into the press, where a steel die in the shape of the roof slams together.
If you had to do it the old way, it would probably take you a week to form one panel. This eliminated the need where you had operators on both sides of the die, and one operator would actually physically put the panel in. The press would roll over, stamp the part. Another person would reach into the press and pull that panel out, and they'd walk over and load it into another die. So the automated system got rid of the need to have people in perilous places. and maximize potential for making more parts.
Automation has increased speed and reduced risks. There are 7 of these monstrous presses in the body shop, keeping up with demand.
This press is running at approximately 15 hours per day. With our 7 transfer presses, we are capable of producing upwards of 25,000 pieces per shift. This one averages approximately 450 per hour.
Speed is only one feature of these $300 million presses. They are also extremely versatile. It's shift change at Bay 12 of the stamping plant, not for humans, but for the massive dies that stamp the Camaro parts. They've just finished stamping bonnets on this line, and now they're switching over to doors, one of the final pieces of the Camaro to be stamped before assembly.
This is basically like a robot shift change where it goes from the one process and changes itself automatically over, getting ready for the next part.
With the stamping dies in position just outside the bay doors, the computer signals the doors to open. Then the stamping dies weighing up to 50 tons roll in on rails.
The equivalent of probably moving almost 2 Sherman tanks when it comes to weight.
The dies are switched out in less than 5 minutes. The presses roar back to life, and the driver and passenger front doors are stamped at the same time from a single piece of sheet metal.
This is making the right and left door outer in a single hit. And then the robot will take it out and present it to the operators for 2 separate racks.
To stamp all the panels takes just 66 seconds. The finished weight of all the stamped pieces, more than 900 kilograms. Now it's time to assemble them. But first, factory workers need something to attach them to. In Camaro car speak, the underbody. And that's built here in the 67,000 square meter body shop. The 3 parts that make up the underbody, the motor compartment, floor pan and rear compartment, are made of galvanized steel. They will be welded together to form one solid structure. The heavy lifting and welding is left to robots, 734 of them. The 3-meter-tall robots effortlessly lift and twirl the 3 parts into position, each weighing over 45 kilograms. Next, robots apply sealer to each of the components, and they are lined up end to end. The pieces are then welded together.
Our welding process here is a DC servo weld system. Our weld guns are electric guns, not air-driven. They use servo motors to open and close the guns, and a DC welding circuit to actually fire the welds and complete the circuit.
The underbody requires more than 2,000 welds. The margin of error is only 1 millimeter. Mistakes building the underbody can be costly.
This is one of the most critical stages of our build in order to establish the design of our car and the integrity of our Camaro.
But perfection doesn't take a backseat to speed.
In 6 minutes, we have the whole underbody completely welded together and structurally sound.
With the underbody finished, it must now pass an examination at the vision station.
When the car comes into this station, The robots take approximately 50 pictures of various holes and locations on the underbody and compare that to our data to make sure that we're building within spec.
The cameras compare the alignments of pre-drilled holes with a schematic of the car stored in the computer. These holes are crucial for assembling many other parts of the car.
If it finds that we're outside of spec on any individual point of more than 1 millimeter, it will reject that vehicle.
Here, a robot detects a potential problem. The computer stops the line.
Right now, we do have a fault. It's rejected, and he needs to physically go up and take a look at the job to make sure it's not damaged.
In the body shop of the GM plant in Oshawa, Canada, robots have spotted a problem and have stopped the Camaro line. An engineer rushes to check the alignment of some holes at the rear of the underbody. He has the authority to override the robot if he feels the holes are not out of the acceptable range.
We have some clearance holes and we have some threaded holes. Everything seems to be fine, even though it's indicating an error, it's minimal. So I'm going to give this the okay. This is going to become another fine automobile.
After 7 years on the sidelines, Chevrolet has brought back its road burner, the 2100 Camaro. At around $24,000 for a V6 model, this heavy dose of high-performance machinery is light on the wallet, but fast off the line.
I can tell you that I've driven a Camaro through my neighborhood and people hear me coming and they come and want to see the car.
The first Camaro hit the streets in September 1966. More than 40 years and 4.8 million cars later, this fifth-generation Camaro picks up where the original left off, combining raw power with that signature Camaro sound. Back at the body shop, it's time for robots to add some support to the underbody. Inner side panels are welded to the underbody, creating a skeletal structure that will support the outer panels or skin of the car. The skin goes on quickly. All the components are sent over from stamping to the body shop, where they're affixed to the underbody. The side panels, the roof, doors, fenders, bonnet, and finally the boot. The Camaro body has been assembled, given a baked-on corrosion protectant, and now it's time to give it some color in the factory's paint shop. Every employee who enters this facility must go through the same ritual.
When we come into work every day, we put on a pair of lint-free coveralls and go through an air shower to make sure that there's no unwanted contaminants spoiling the paint finish of your vehicle. The air blows off all the dust and lint to help make sure that we don't ruin the paint job of the vehicle.
If small particles get trapped under the paint, they could form air pockets, which will erupt into craters on the Camaro's finish when it goes through an oven to bake on the paint. But before any paint can be applied, every car entering the paint shop must undergo an extensive sealing process, first by robots. 4 floor-mounted cameras snap photos of the underside of the Camaro and relay the pictures to a computer, which ensures that the car is perfectly aligned to be sealed. If everything is okay, a signal is sent to the robots to go to work.
We apply paint shop sealer on all the seams of the vehicle. We seal the passenger compartment, seal the trunk and the wheel houses. This step of the process ensures that our customers don't have a vehicle that leaks water.
It's similar to the way a bathtub or sink is caulked. This is so critical to the build of the car that another coat of sealant is applied, this time by humans.
People are very important to the process. Our automation applies the bulk of our products to the vehicle, the paint, the sealer, but we do rely heavily on our highly trained and skilled workforce to make sure that the automation is putting the appropriate surfaces on the vehicle. So all of our sealer inspection and our prep work and our final inspection are done by our production team members.
After every car is thoroughly sealed, it goes through a final white glove inspection before the primer coat goes on.
We look for any little imperfection that might cause another defect further along in the process. It's important to get this any dirt or any other imperfections off the job at this point, otherwise it's going to be a more detailed repair later in the process.
Next, the car heads for the primer booth, where it's blasted with powder primer. The primer is electrically charged, so as it's sprayed directly at the car, the metal body acts like a giant magnet, attracting it to the surface of the vehicle.
It's almost like a magnet where the charged particle gets attracted to the vehicle itself. Once it goes through an extremely high temperature oven, which then turns that powder into a liquid, and then that bakes onto the vehicle to form a hard surface.
Before the car can receive its color coat, there's one last bit of housekeeping.
Well, prior to the car coming into the booth, we have a feather duster, which is basically made up of ostrich feathers, and it dusts the car and try to remove any lint or loose dirt that could create a defect on the car that will get baked into the paint.
Finally, it's time to apply one of the 10 bold colors.
There's a label on the car itself that has the information as to which color and options are on that car. And there's another reader in front of the spray booth that'll identify the skid based on a barcode. And in the computer system, it looks up to see which options are for that car.
This car is barcoded for red. From this point forward, we'll be following it through the rest of the assembly process. As a car enters the paint booth, it trips a switch, activating the robots.
The robots will then go through a pre-programmed robot path, spraying the different areas of the cars. Some of our robots are used to open doors and open hoods and deck lids.
The paint is sprayed on as a fine mist and spreads out evenly across the surface of the car. Amazingly, at the same time, one car is being painted red, the car right behind it is being painted yellow, without so much as a drop of the wrong paint color ending up on either car. Like the primer, it's applied using electricity and magnetism. The paint shop has 5 paint booths, which apply all the different colors. Each line paints up to 40 cars an hour. The Camaro now goes through a heated flash oven, drying the paint to the car. Then, a clear coat is applied, which is baked on, giving the car a smooth, flawless finish. After spending 25 minutes at 135 degrees centigrade in the oven, inspectors examine the job.
Well, we're inspecting the final clear coat on the paint for dirt, imperfections, anything that shouldn't be there. And if we find any, we sand them, polish them out. Well, we're basically the last stage before the customer gets the car, so it's pretty critical. Make sure we get all the imperfections out.
Something catches this inspector's eye.
It'll work for a second. There's a... Well, we sanded there's a piece of
dirt in the clear coat. So we just sanded the dirt out. Now that's polished, and I'm just going to buff it out, and it'll come back up shiny the way it was to start with, hopefully. It's all nice and shiny like it was originally.
After spending 8.5 hours in the paint factory, the Camaro finally leaves looking showroom ready. It now heads into the trim area where the car doors are removed to make it easier to build out the interior. The doors will rejoin the car near the end of the trim process.
Trim shop is the first department after the car is painted, and we do everything from the wiring through the carpeting, the glass install, the seats install, a lot of the final moldings before we send the car to chassis where we begin to install the engine.
First, the electrical wiring is snaked through the vehicle. It controls everything electrical in the car, from the surround sound stereo system to the seat warmers and headlights.
The main body wire harness would be the lifeline of the vehicle. Everything needs to be in place that would be just like the human body. What you see here, these employees are very similar to a pit crew you would see at NASCAR or Formula One.
They'll wire 440 Camaros in an 8-hour shift. That's nearly a car a minute.
Yeah, this is just putting all the electrical that goes to the trunk and the rear lights, stereo system, and various other things go through this wiring harness. And the obvious controls at the front.
The car is now wired and it's ready for its dashboard. Technicians use special hoists to lift and load the dashboard.
One of these dashboards weighs 250 pounds fully dressed. That is why we need the arm to assist where we don't have to hand bomb them in. And it has protection on it, so if we accidentally hit the car with it, we will not dent it or scratch it. Without the arm, it would be impossible to do it because we install a dashboard every 40 seconds, 440 times a day. The most challenging part is to load the IP the first time, to make sure you get through the studs and all the holes where we can keep up our pace of doing the job every 40 seconds, where we don't have to stop the line.
The dashboard is aligned using bolt holes in the door jamb and a laser leveler.
The laser levels ensure we get the proper height in the car for the rest of the trim will fit, where we have proper fit and finish.
With the dashboard level and lined up with the holes, there's only one thing left to do: bolt it in. Next, the front and rear windows are installed.
Operators load the glass into the machine. Then sealer is put onto the glass. After that, the glass is presented to the opening in the car. Lasers measure the opening, make adjustments, and do a perfect load every time.
Working as a team, the robots install both the front and rear windows in just over a minute. By now, we're nearly 10 hours into the build process. Next up is the seat installation.
You line these hooks up with the holes in the floor, placing it through the car, making sure it's lined up square. Set it down easy in there. Take the arm out. Set the headrest in. Now I got to make sure that it's seated properly. Push the head, make sure it's locked in, and then do the wire harness up for the power seats. This clips into a connection on the floor. Set it down, check that it's locked in. That's it.
With the trim process almost complete, this car is now ready to be remarried with its doors, which were removed after painting so that workers could access the car's interior more easily. The automation and timing is so sophisticated and precise that the doors on the red Camaro were taken off at the far end of the trim plant, separated by more than 27,000 square meters and 130 cars, yet they join up at precisely the right moment to be installed on the body of the car.
Right now I'm going to load the door onto the car.
The hoist effortlessly rolls the 23-kilogram door into position and locks it in.
And then I fasten the two bolts. Upper and lower.
The technician will repeat the process for the passenger side door. The Camaro looks like it's ready to hit the road, but it still needs the 304 horsepower engine, transmission and powertrain that will power it down the road. We're building the comeback muscle car of the century, the 2100 Camaro. Now it's time to assemble the heart of this roadster, the engine. The factory that builds both the V6 and V8 motors is GM's St. Catherine's powertrain facility. Here, in this 140,000 square meter factory, high-tech robots are pushing the limits of engineering.
There's about 55 automatic stations, and they involve a variety of different types of robots.
The primary components of the V6 engine are the cylinder block, cylinder heads, and crankshaft. Inside the engine, the piston and rod assemblies connected to the crankshaft help deliver the power to the car's wheels. The crankshaft, which rotates the wheels, starts out as a roughly shaped steel forging. It's slowly transformed into a finished part by a milling machine.
It's full of carbide inserts, which actually mills the steel off the crankshaft. It probably takes off about 100 microns, about 4/1000ths of an inch. It's very precise.
On another line, a hole is being bored in the aluminium engine block for the crankshaft, along with 6 other holes for the aluminium pistons that will power the Camaro's V6. The precision cuts are made by a diamond-studded drill bit.
As this is rotating, it moves up and down in the bore, and it takes off a small amount of material in each step. It is the surface that the piston rings contact. The surface finish is critical, the dimensions are critical, and if it's off a bit, you would lose compression, and it would affect the performance and the horsepower of the engine.
With the holes machined on the engine block for the pistons and crankshaft, it's time to marry everything together on the engine assembly line, starting with the engine block. The crankshaft is first installed into the engine block. Then it's onto the next automated station, piston stuffing. 6 aluminium pistons are now carefully slid into the engine block's holes. They're lubricated with oil so they won't scratch the cylinders. Placement must be perfect. If the robot is off by as little as a few hundredths of a centimeter, it could damage the engine block. The V6 is nearing completion. A technician inserts the bolts that hold the cylinder heads in place. With 304 horsepower, you'd think this muscle car engine would suck down petrol like a bodybuilder sucks down steroids. But the Camaro V6 has a petrol rating of 18 miles per gallon in the city and 29 miles per gallon on the motorway, keeping it from being subject to the gas guzzler tax. It operates so efficiently because of SIDI, Spark Ignition Direct Injection. It's Camaro's most highly advanced technology. Contrary to most fuel injections, where there's air-fuel mixture intake, this only has air in the intake, and the fuel is sprayed directly from the injectors into the cylinder, which allows for a more efficient burn. A computer-controlled DC electric wrench torques all the bolts simultaneously, fastening the cylinder head to the engine block. The wrench is running at a speed of nearly 100 revolutions per minute. The cylinder heads must be fastened perfectly to seal the combustion chambers and the oil and water passages. To complete the build of the V6, the timing assembly is installed.
Have to tighten everything down, tensioners for the chain. And then it's ready for the next chain.
One of the more unique factory-built Camaros was the ZL1, which was specially designed for racing. It featured a 430 horsepower V8 engine and the first aluminium block ever made by Chevrolet. At only 225 kilograms, it was probably the most powerful engine ever put into a consumer-produced Camaro.
It was very high torque, high horsepower, and very light. We have a big block, all aluminum, specifically designed for super high performance. As far as American vehicles, that was incredibly exotic.
With its lightweight, high-powered engine, the ZL1 was fast. It could travel 400 meters in 12 seconds at 190 kilometers per hour, making it the fastest Camaro Chevrolet has ever produced. Only 69 were ever built. With the engine finished, there's only one thing left to do. Electronically fire it up and make sure it's working before installing it under the bonnet. The Camaro V6 engine passes the test, and it's ready to be shipped to Oshawa to join the car on the assembly line. V6 and V8 engines, built at GM St. Catherine's powertrain factory, have been shipped to the Oshawa plant. Here in the chassis area, they are ready to join a Camaro in the making. With hundreds of engines, each destined for a new Camaro from the trim area, how does the operator know which engine belongs to which car?
When a car finishes the paint process, there's a scanner that reads that car and says, I identify you, I know which car you are, I know your build content. That information gets stored in a computer system. That computer system is linked to all of the other build processes through the assembly line, one of which is right here. And we pull the information from that computer in order, and it tells this guy, amongst others, this is what you need to do and when. So he uses this tractor assembly behind me now, picks off the racks that are delivered from St. Catherine's, places them on the pallet that begins the build process.
Workers connect the exhaust valves down pipes and fuel lines to the engine. Next, it's time to marry the engine with a critical piece of the powertrain that kicks this muscle car into gear, the transmission.
As I come up to the cradle, bring the engine up, the transmission up, lower the transmission, make sure it sits in there properly, marry it together, and release the cradle. Hoist, and reload it to the next transmission. Return back to the transmission again, and secure it.
11 bolts secure the transmission to the engine. Meanwhile, across the way, strange vehicles snake their way through the chassis factory, delivering parts and sub-assemblies to the main assembly line. They're called an Automated Guided Vehicle, or AGV.
Effectively, you could call an AGV a self-propelled robot. It is an independent piece of technology. It's got its own drives, its own controls, and it knows where to go and what to tell the operator to say this particular car needs these parts.
At this station, the AGV tells workers to load the Camaro exhaust system and install an engine mount.
The AGV is a pretty sophisticated piece of technology. They use radio frequency technology to communicate back to another computer, telling these operators which exhaust to pick for that particular car, which engine cradle, and so on.
Now, one of the most exciting moments in the assembly, the link-up of engine and transmission to the chassis. And here, it's a bit like watching the space shuttle land. The engine swoops in on a conveyor from above, lines up on approach with the AGV while workers guide it in. And touchdown, the 304 horsepower V6 engine has landed.
My kids all think it's great that I'm building a sports car, and it's just nice to know that this is kind of like the brain of the car, and we get to help put that together.
To handle the 304 horsepower engine of this muscle car, the Camaro relies on a sophisticated braking and suspension system, even more so on the high-powered V8. Bringing 1,724 kilograms of muscle to a dead stop takes some well-engineered brakes. Braking is accomplished with 4-piston Brembo caliper brakes equipped with 36.6 centimeter aluminium disc rotors. When these discs are grabbed by the 4-piston Brembo calipers, the Camaro can claw to a halt from 97 kilometers per hour in 33 meters. Up front, a McPherson strut suspension utilizes a shock absorber and a coil spring, which helps for precise steering, ride, and handling. The Camaro has independent rear suspension, a multi-link design working in concert with the McPherson strut front setup. Once the chassis is complete, it's ready to be married to the body, and it's a spectacular sight. It's time to park a flying 1,361 kilogram body onto a moving chassis. At this ultimate GM factory in Canada, the Camaro is nearly complete. Still in the chassis area, one of the biggest challenges remains, marrying the flying body onto a rolling chassis. The AGV approaches and stops. At this point, engine and chassis are facing opposite directions, and a crash landing appears more likely than a perfect one. Then the AGV pivots, making a sharp left turn, and the chassis lines up under the body, but slightly ahead of it. The AGV knows to stop and let the body catch up. Slowly, they inch their way towards each other. Once they're lined up perfectly, the AGV hydraulically lifts the chassis towards the body. But before they can merge as one, the AGV stops and waits for a worker to take over. As reliable as these motorized robots are, the final connection is left to humans.
Our job is marry the chassis to the body. We line it up, this cylinder to the pole, the front first. When you go to the second, the rear, line it up. When it's lined up, you just guide the strut. Then second part is secure it with 2 bolts. I put 2 and the guy in the front puts 3. The hardest part is just to keep up with the line.
Remarkably, in less than 30 seconds, the body and chassis are one. All that's left now to finish the build of the Camaro is to put on the rear bumper. and the classic front grille. And then add the wheels, a key component of handling performance. The Camaro offers 3 different thicknesses of wheel.
So the first operator puts the wheels on the car. The second operator has what's called a wheel multiple spindle tool that he uses to secure those wheels to the car.
These bolts do more than just secure the wheels. They signal the end of the build process.
It's effectively the last bolt that's put on the car. 18 hours ago, we were looking at a bunch of sheet metal sitting in a basket with no shape or form, didn't look like a Camaro at all. 18 hours later, we're getting set to drive a Camaro off the end of the line.
The Camaro roars to life for the first time. But before it can graduate to the road, it must make the grade. First, check the alignment, which is done from below the car.
Okay, now I'm going to go up and check the front and rear alignment of the car. Every car has to be towed in properly before it leaves. So now I double check the rear and it's within spec, so that's okay. So now I'm going to do the left front alignment. I watch the screen and I bring it down into the green area. And I snug the nut. Check the right front. I watch the screen as I do everything and make sure we got green lights. Now I have to torque each one out. Make sure nothing gets out loose. Now I double check the screen to see that I have all green lights and this job is good to go.
The Camaro now heads into the diagnostic vehicle test station, which zeroes in on the car's acceleration and braking.
It's going to pick the car up and put it on a set of rollers.
Once on the rollers, the driver takes the car up to 113 kilometers per hour, ultimately surrendering control of the car to the machine.
That pulsing that you're feeling is the ABS testing the brakes. Now I'm just applying into a green arrow section. That tells me we've passed the test.
One last critical test remains before this Camaro can hit the road. It must go through a simulated downpour.
This is a final inspection for the Camaro, which has been on the line for 18 hours. It's a very important test, and I'm about ready to take it through the water test.
For nearly 8 minutes, the car is pounded by a torrential downpour. The goal, see whether there are any leaks around the windows, doors, boot, or seams. If so much as a drop of water seeps inside, this Camaro will be dry docked. 4,000 litres of water per minute pummel the car.
We check around the sunroof to make sure there are no leaks. And we have to listen to make sure that there are no drips coming from the back window. Not leaking from the sunroof. It's dry. The windows are very solid. The seals are very solid.
So far, all is dry, but there's still the boot and doors to check.
At this point, I'm checking for leaks around the edges and in the trunk. The other door.
And the verdict is?
This car is ready to go.
After 7 years of being away, the classic muscle car is back on the road. The Camaro announces loud and clear that it has made a comeback, and it is better than ever.
There's more state-of-the-art engineering at the same time tomorrow. Stay tuned to National Geographic Channel for a gripping air crash investigation.